Okay, past exam paper, exam 1 for maths methods. This is the VCAA 2007. Let's go. We're going to look at the solutions. Alright, question 1. So, usual questions. We've got a function, we've got to work out the derivative. So here we've got function divider function, that is a quotient rule application. Okay, so make sure you look up the formula sheet on how to use the quotient rule and label the parts appropriately. The top function is the u function, and the denominator, the bottom function, is the v function. And you piece them together using this rule. There you go, there's your quotient rule. And we should get something like that. And from there you can go ahead and factorize. You can get an x squared factor out. Okay, there you go, that will give you 2 marks. Okay, if you didn't factorize and you left it as the previous line, that is also okay, that's also 2 marks. Question 2, let's solve the log equation. So, you've got to use your log laws here. You've got log of something plus log of something means that the 2 parts inside the brackets will multiply. There it is. So, expand the brackets, 2 times 3x plus 2 times the 5. Now convert it to an exponential number. There it is. E to the power of 2 on the right hand side. Subtract the 10, divide the 6. Okay. So log laws are important. Next bit. Alright, so here we've got a function inside a function. So this is a chain rule derivative. Okay, once you find the derivative, then you evaluate it at pi on 4. So first off, let the inside function be u equals tan of x, and so the derivative of tan with respect to x gives us sec squared x, and you can get that from your formula sheet at the back of the exam. Okay, now that will give us, the outside function will be a g of u, so we've got a log of u, and we differentiate that and we get 1 on u. So that ends up being, when we put it together, there's your chain rule, the multiplication of the 2 derivatives. It's a 1 on tan, where u is your tan function, times sec squared. Now expand that out into sine and cos factors, and we get this, and you've got a common factor of cos cancelling out, and there's your derivative. Now we're going to evaluate that at pi on 4. Substitute pi on 4. Sine of pi on 4 is the same amount as cos of pi on 4, root 2 on 2. So that gives you 4 on 2, which is 2. Okay, now question 3. The diagram shows the graph of a function over with a domain of all real numbers. So you can see it's a hybrid function. Now we go to, for the graph shown above, sketch on the same axis the graph of the derivative function. So we're thinking about the rate of change of these curves. So the rate of change of a negative parabola will be negative linear. The rate of change of a positive linear will be a positive constant. And the rate of change of constant is a 0. There we go. Now here we have a cusp. We have the 2 graphs joining, but they're not smooth. The derivative is not continuous, so it's non-differentiable at that point. We must have an open dot. Same here, open dot. It's non-continuous graph, so it's non-differentiable. We must have an open dot. And there it is. So there's the graph of our gradient function. Make sure you have the right endpoints. So now write down the domain of the derivative function. Well, it's all real numbers because it goes to negative infinity, goes to positive infinity, all real numbers except for at 0 and except for at 3. Next question. Now there's no question 4 to be concerned about because that has been omitted from the 2016 study design. So there's no related rates of change problems for maths methods for 2016 and onwards. Okay, so question 5, probability. Now if you read through this carefully, we will identify that it is in fact a binomial distribution problem. It is known that 50% of the customers who enter a restaurant order a cup of coffee. If 4 customers enter the restaurant, what is the probability that more than 2 of these customers order coffee? Assume that what any customer orders is independent of what any other customer orders. So all that description there is one of the important assumptions for it to be binomially distributed. So let's define the variable. Yes, there's x is a discrete random variable, the number of customers ordering coffee. X is binomially distributed with number of trials is 4 and the probability of success is a half. Whereafter x is greater than 2. Well, for discrete numbers, that has to be an x equals 3 and an x equals 4. So we're going to have the number of combinations of 3 out of 4 things. So, and probability of success to the power of 3, probability of a failure, 1 minus a half, which is also a half, to the power of 1. So that's the structure of the binomial distribution formula, and you must remember that and know how to use it. Some important things here. There we go. Combinations of 3 out of 4 things. Well, because it's n minus 1 out of n, it's always going to be the n amounts for the combinations. And 4 out of 4, when it's the same numbers there, always has a combination of 1. So you need to be able to simplify them easily. So important things in general, whenever we have the structure as a combination, well, that is equal to n things. And if we have a n things out of n thing combinations, well, there's only one combination of doing that. So important things to remember there. Okay. So this can be done by hand, especially little things it's testing is, do we know how to go 2 to the power of 4? 2 times 2 times 2 times 2. Okay, you have to be able to think about that. A little bit of numeracy skills. Please practice your powers of 2 at least. Have to know how to do this without a calculator. Alright. Next question. Question 6, another probability one. So we've got 2 events, events A and events B, from a given event space. Now they are such that the probability of A is given by that, probability of B is given by that. So we're after this one. Probability of not A intersect B. The best way to think about what that is doing it on a Venn diagram. So let's examine a Venn diagram. There it is. So that's this region. Okay, that there is not A intersecting with B. And as you can see, it's the whole circle B, but we subtract the inside bit. So it's probability of B minus the probability of A intersect B. And we've got those amounts, a third minus an eighth. There we go, 5 24th. Now calculate the same thing when A and B are mutually exclusive events. So they mean that they are disjoint events, okay, or it means that the probability of the intersect is 0. So in that case, that's correct. It's just the same as the probability of B, which is a third from the information. There it is. Okay. Next question. Now we're on to some circular functions and some antiderivatives involving circular functions. So this kind of problem is integration by recognition. Got to draw on the derivative fact first before we can do the antiderivative. So there we go, the differentiate our function of x, and it gives us that. And what's important to recognize from that is this part here is what we want to find the antiderivative of. So we've got to transpose for that part in our expression. There we go. Subtract the d dx term over to the other side. And now let's divide by the 3. Alright, so now the integral of the left hand side, that's what we're after, the integral of this term. It's the integral of the right hand side. And integrating each term, the integral of the second term here just cancels out the derivative, so you're just going to get the x cos of 3x, what's left over inside the bracket. And there it is. Okay, now thinking about this circular function, f of x, we're first going to solve this equation. Okay, so look at the domain. This is for x numbers from 0 to 3. So when we're solving circular functions, it's important to get an adjusted domain as well. So first off, we need to do the inverse sign of the right hand side number. Now let's think about evaluating the inverse sign of negative root 3 on 2, but we want it across this adjusted domain. So if x is from 0 to 3, then 2 pi on 3 lots of x ranges from 0 to 2 pi. So check the unit circle. Sign is negative, that's this negative value there, in the third and the fourth quadrant. And if we look up our table of exact values, we will have a pi on 3 angle. So it's the 4 pi on 3 and 5 pi on 3. The two angles we're after, both of those angles. Okay, now let's transpose for x. Multiply by the reciprocal of this factor. And we get 2 and 2.5. Now what's important is to check, are those values within our domain for x? Yes, they are. Good. So it must be correct. Okay, next question. First off, let's form our g of x function. Now g of x is given by this transformation here on our f of x. So what we have to do first is first we subtract 1 from the x, then we have to times by 3 of the whole outside function, and then add 2 at the end. Okay, and we get this. Okay, now find the smallest possible value of x for which g of x is a maximum. Well, maximums occur when the amplitude adds on to the middle line. So when g of x is equal to 5. So let's solve when g of x is equal to 5 for x. Let's set up that equation. Now we will get here subtracted 2 divided by 3, and it is equal to 1. So the inverse sign of 1, and that is a pi on 2. Okay, now let's transpose and solve for x, and there it is, we get a 7/4. Now the next question, you have to think about calculus, and we're finding the equation of the normal to the graph. This is a perpendicular line, it's perpendicular to the tangent. Alright, so have a look. E to the power of an x on 2 plus 1, and the normal is shown as well. That's this line here, there's your normal to the exponential function. Alright, so first off, let's get the equation of the tangent. So if we know the equation of the tangent, then we'll be able to go from there and work out what the normal is. So first off, we can see that the tangent and the normal cross the y-axis. Well, that occurs when x equals 0. So finding the dy dx or df dx, the derivative of the function, and evaluating x equals 0 is going to give you the gradient of this tangent. Substitute x equals 0 and we get a half. So there it is, that's the gradient of your tangent. Now the gradient of your normal line is this relationship, the negative reciprocal of the gradient of the tangent. So it's a negative reciprocal of a half, which gives you a negative 2. So there's the gradient of the normal line here. That's a negative 2 gradient. Now, you've got to keep in mind that this line passes through this point here. That's when x is equal to 0. And if you put x equals 0 into your function of x, we're going to get y is equal to 2. So this is the point that the line passes through, 0, 2. Now we use our formula for the equation of a straight line. And we use our values. Negative 2, x1 is 0, y1 is 2. And there it is, y equals negative 2x plus 2. Now from that, we have to find the exact area of the shaded region. So from our equation of the normal line from the previous question, the x-axis intercept is when y is 0 and that's when x is 1. Okay, so that's important because that's where the shaded region ends. Now the area is the definite integral from 0 to 1. And we're evaluating that definite integral, there we go, of the function. We evaluate the definite integral as the function subtract the normal line. Okay, the top function subtract the bottom function. And we take the antiderivative of each term, simplify, and substitute 1 and 0 in there, and evaluate the definite integral, and we get this as our area. Okay, next question. So now the area of the region bounded by the curve with equation y equals k times x to a half. So that's like the square root of x. Now x is a positive constant. Now it has to be bounded by the x-axis and the line with equation x equals 9, and that area is 27. We've got to work out what k is. Okay, so area bounded by a curve is always a definite integral, and there it is. Definite integral going from 0 to 9 of the function, and the area is equal to 27. Now let's have a look at the function as a little graph. There it is. That's our region we're trying to find. The region between the x-axis, the y-axis, and the curve. And up to this 9, this x equals 9 number. Okay. So, integrate, let's find the antiderivative. We add 1 to the power and divide by the new power. And we get this. And when we substitute 9 in, we have to recognize that 9 to the power of 3 on 2, well, that's the same as the square root of 9 and then all to the power of 3. Well, we know what the square root of 9 is. That's 3, and then 3 cubed, 3 to the power of 3 is the number 27. There it is. Okay, so little important things here. A to the power of an m on n. Well, what's that the same as? That's the same as the nth root, and then all to the power of m, or we could have a to the m as an exponential number and then have that inside the nth root. Both forms are both equivalent. Okay. Alright, so evaluating that, the 27s cancel nicely. You can see that they cancel out, and we get k is equal to 3/2. Very good. Alright, we're coming close. This is almost the last question. Question 11, big probability question. Now this one requires a tree diagram. Now there's a conditional probability events happening. We've got one event which we're going to call F, and it's that flight depart on time, and the second event is that weather is fine. Okay, now from the information we've got this one. Yep, F given W is 0.8, and we've got F given not W is 0.6. And we've also got probability that weather is fine, which is 0.4. Okay, now how do these all piece together? There's a little tree diagram. Okay, now each branch sum to 1. So this probability plus this probability is equal to 1. This probability plus this probability is equal to 1. And these original branches also sum to 1. So that's how we can work out all the possible probabilities. Now, the probability that the flight from Paradise Island departs on time. Okay, well, that's the probability of F only. Now that is, we can come up with this rule. This is the law of total probability. Okay, and that is taken from considering both the situation when the F is on the W branch and the F that is on the W not branch. We've got our values and we substitute and do our multiplication and add them up. There we go, 68%. Now let's find the probability that on a particular day in March that the weather is fine on Paradise Island, given that the flight departs on time. How nice. So that's this conditional probability statement. And we can use our rule in a clever way. Now the intersect, F intersect W, well, that's the multiplication rule in this form as well. F given W multiplied by the probability of W. And we know those values from the tree diagram. Now the probability of F dividing by the probability of F, that is the answer from the previous question. There it is. 32 on 68, and we simplify it. 32 on 68, halving each time, and we get an 18 on 17. 8 on 17 as a simple fraction. Excellent. Okay. Work with fractions. We've got to be good at our numeracy. Now, last question. Now, this is all about getting this line segment, OP, to be a minimum length. Now, whenever we're trying to minimize a value, we can use calculus. So, first off, there's the equation of the line that point P is on. There it is. Intersects on the y-axis at 10 and on the x-axis at 5. Now let's put our line segment in from 0 to P. Now we want to make this line segment from 0 to P a minimum. So we use the length of our line segment formula, and we need 2 points. One point is the origin, 0, 0, well that's okay, and the second point, point P, is our unknown point, x, y. So it becomes this. It's like Pythagoras' theorem. But the y coordinate is given by this rule, because it's a point on the line. So let's substitute that in. And expand the brackets and collect like terms. Okay, so that is our formula for the length of the line segment O to P. Now, what is the minimum value? Well, that occurs when the derivative of that with respect to x is equal to 0. So let's differentiate. The derivative of the inside function, there it is, comes out, and times the derivative of the outside function. That's why we've got this negative a half, and we've got the half out the front. Now, if that is equal to 0, then only one possibility, it's the 10x minus 40 has to equal 0. It's because this part here to the power of a negative a half, it's a square root in the denominator. Well, that can never equal to 0, because if the denominator is equal to 0, then it's undefined overall. And that's not good. So it has to be this that is equal to 0. And from that we get x equals 4. Okay. So we substitute that value back into our line, and we get our y coordinate 2. So there's our point, x equals 4, y equals 2, and that means at that point the line segment OP is minimized. What is that minimal value? Substitute those numbers into the line segment, and we get the square root of 20. Got to express that as a simple surd. 2 root 5 units in length. And we are done. Well done, everyone. What do you think? I hope that was helpful. Please review those questions and study, study, study.